Okay, building a swimming pool with and the sidewalk around the pool. Actually, we're building a sidewalk. Here's the sidewalk around the pool, and it is of uniform width, which means the width of the sidewalk here is the same as it is here, same as it is here. It's all the way around the same. The pool is 100 feet by 60 feet, and we have 1,700 square feet of concrete to create the sidewalk. What should be the width of the sidewalk? So let's figure out, how wide this should be right here. Okay, if we want we want to figure out the area of the sidewalk right now. So what would this area right here be? What could we use to represent that area? We know the height would be x, but what would be the length going across right here? Okay, so you have x here. Well, this right here is x from here to here. This is also x from here to here. And then this distance here is 100. So if I want to find the area of this part right here, I'm going to do the height of that, which is x. I'm going to multiply it by 2x plus 100. 2x plus 100 is this length right here, all of this. 2x's on the end plus the 100. And then I'm going to multiply all that by 2, because that would give me the area down here. So far, I have the area of the top and the bottom, and it's represented with this expression. Now, what am I missing? Well, I need to find the area of this and the area of this and add it to this right here, and that would give me the area of the entire sidewalk all the way around. Well, you have x going across right here, so this is x. So I'm going to have x, and then I'm going to multiply with the height, which is 60. So this would be 60x. Then I have another one over here, so I'm going to times this by 2. So with these two expressions, I have, that's representing the area of the entire sidewalk. So I'm going to rewrite this as 120x, that's what this is, plus, this is 2x times 2x, that's 4x squared, and then 2x times 100, which is 200x. All right, now that represents the area of the entire sidewalk. Let's combine like terms. We're going to have 4x squared, and then 120x plus 200x is 320x. That represents the area of the sidewalk. Now we have 1,700 feet of square feet of concrete, so we set that equal to 1,700. And if we solve this equation, we're going to get x, which is the width of the sidewalk. So what I believe I can do is I can move everything to the same side. 4x squared plus 320x minus 1,700 equals 0. I'm going to divide everything by 4. Might make this a little easier. So x squared plus, what's 320 divided by 4? That'd be 80x minus, and then what's 1,700 divided by 4? It's going to be 425 equals 0. So now we can factor this, or do quadratic forming. I believe this is factorable. This negative right here tells me the signs are going to be different. Because we have 1x squared here, just an x squared, that means I can put an x here and an x here and set all this equal to 0. And now we need two numbers that multiply to give us 425. And since the signs are different, they're going to have a difference of 80. So a difference of 80. So what about 120? They have a difference of 80. But if you take 100 times 20, you're going to get 2,000. And that's way too big. I need 425. So let's not use 120. Let's make them smaller because we want a difference of 80. Let's see, 85 and 5. So that has a difference of 80. And if you take 85 times 5, actually you're going to get 425. So that's what the numbers are going to be. Now, since I have positive 80x, I really want the 85 to be positive and the 5 to be negative. And now when I set those equal to 0 and solve, set this equal to 0 and solve, we minus 85 minus 85, x equals negative 85. You can't have a negative length, so it's not going to be that answer. Here I'm going to add 5, so x equals positive 5, and that's what it should be, 5 feet.